Okay, so now we have the Power Perfect filter again. You can see that's powered on. The LEDs, oops, they're not on, sorry. This shows that they're not on. So the LEDs are not lit. And then we'll take a look at the oscilloscope. So there is dirty electricity in this home that I'm testing. And you can kind of see the scale. I have a 100 millivolt scale. And so if we count this, we've got somewhere around 100, 200, 300, 400, 500, about 2 volts. Take that back, 1 volt overall peak to peak, and the waveform is quite choppy. So I'm going to turn the filter on, the Power Perfect filter. Now it does reduce the DE. However, as we already previously showed, it's drawing 6 amps to do that. Each filter is drawing 6 amps. So there's 2 portions to the filter. They're both on. So each of these are drawing 6 amps for a combined of 12 into your power bill for running the Power Perfect filter. So I thought you'd find that very interesting to see, the waveform, what it does. It kind of took out some of the big peaks, but you can see that the waveform is still quite choppy. It's nowhere near what it should be, but it did do something. If I look at a Stetzer gauge, I'll plug that in next. I'll plug that in to the same side I'm measuring. Pardon me while this all going on. So right now it says I'm reading 145, 172, 180, 180 approximately with the filter on. I'm going to turn it off. See what we get. 200. So it went down from 200 to about 180. 185. It's not a big drop. So generally speaking, less than 50 would be preferred. But it did make a slight drop, not a big enough drop to make it safe. So my conclusion on the Power Perfect filter is that well, it does something to help, but it draws 6 amps per module, which is a total of 12 amps. So it may help reduce the GS units from a little over 200 to about 180, but at what cost? At 12 amps, 7 by 24, that's going to increase your power bill, not reduce your power bill. So I wanted to point this out to you. If you have any questions, give me a call at 256-570-5434. Thank you.